Hi everyone, welcome to week 3 of our course in the history of mathematics. This week we take our first steps into the modern world with two of the greatest mathematicians of all time, Isaac Newton and Leonard Euler. You've probably heard of Isaac Newton before. He made significant contributions to physics and astronomy and calculus. What you might not know is that the underpinnings of calculus and some other things depend on a generalization of the binomial theorem that Isaac Newton developed. The binomial theorem is just like what it sounds. You have a binomial and you want to raise it to a power. If you do that, you multiply out, you get all of these middle terms. You can predict what these middle terms are using Pascal's triangle. Newton took this a step farther than his predecessors, though, by considering what might happen if the power on that binomial is something other than a whole number, like maybe a fraction. There are some interesting consequences of Newton's binomial theorem. One is that he came up with an effective and beautiful approximation of pi. In fact, his approximation of pi is the first new approximation of pi essentially since Archimedes, in the sense that all of the approximations of pi from Archimedes up to Newton used essentially the same method until Newton came along and used the binomial theorem to approximate pi. Newton also is responsible for developing the calculus, and the binomial theorem was an important part of that as well. We'll be seeing a little bit about how that happened. Now, we are also going to be talking about Leonard Euler this week, and it's possible that you've not heard of him, but he is perhaps the greatest mathematician that ever lived on this earth. He was a very prolific mathematician. His publications include 80 volumes of work, and after he passed away, it took journals 54 years to account for the backlog of his unpublished articles. Now, we could spend an entire course talking about Euler's work, which spans a great many topics, but in our course, we're going to talk about one particular accomplishment, and that is his solution to the Basel problem. So the Basel problem is a problem about adding up numbers. On the right-hand panel, you'll see an equation that I've written. On the left side of that equation, you'll see the sum of reciprocal squares. That is 1 plus 1/4 plus 1/9 plus 1/16, and so on and so on. And beginning with the Bernoullis, who lived a generation before Euler, they had put forth this challenge about what the sum of this series might be. That is, if we were to add up all of these reciprocal squares, what might the answer be? And no one could figure this out until Euler did as a young man, and he discovered that these numbers should add up to pi squared over 6, which is a rather remarkable result because this pi in the answer just sort of pops out of nowhere. Where is it coming from? And we will see this week a little bit about where that comes from. In the investigation of the Basel problem, we'll see that trigonometry plays a role, and so I thought that this might be a good time for us to learn a little bit about the history of trigonometry. We'll be talking about some of the figures that were involved in developing trigonometry, including Claudius Ptolemy and Regiomontanus. Well, there's a lot of interesting things to look at this week, and I hope that you enjoy. Best of luck.